So welcome and congratulations, session 5 of day 2. So thank you for finding the session and joining us, as well as thank you for being with us here at the summit. I know I stand between you folks and a very nice reception. So with that in mind and the amount of content we're going to cover, I would only ask that you defer your questions till the end. I will stay up here at the front of the room and answer whatever questions you might have. I'll stay as long as needed to get them all out. So I am Young Kim. I'm the Global Business Development Manager for Amazon's Elastic File System, Amazon EFS. And what I'd like to do today, in the 50 minutes or so that we have, is to go through these 4 topics. First, I'd like to start with the why of Amazon EFS, and then talk about when to use the Amazon EFS in relation to the other storage services. Then I'll dive into the technical concepts, as well as security. I'll also focus a fair bit of time on Amazon's performance in terms of its design, its characteristics, and how to optimize. And lastly, I'll close with Amazon's economics, or EFS's economics. So before we get into the whats and the hows, I thought it'd be worthwhile to position it in the context of why Amazon EFS. So when AWS launched in the cloud, we essentially gave customers 2 options for storing their data. We gave them block storage in the form of ephemeral and EBS, elastic block storage. We also gave customers object storage in the form of S3 and Glacier. But there was one category of data storage that was missing in our portfolio, and that was the broad category of file storage. And so why this is exciting and why I think this is very relevant today is there are, depending on which analyst estimate you use, IDC, Gartner, the estimate is that up to 80% of existing unstructured data is native in file systems. So these are applications that are used to mount points and shares and directories and human-readable file names like my.doc. So the Amazon EFS data storage service really completes and complements the rest of the storage portfolio by providing this final piece, right? The file storage option for our storage services. Okay? So that's a little bit of the background as to why Amazon EFS, and it's June. It's just about to celebrate its 1st anniversary this month. So we think Amazon EFS is highly differentiated and unique in the industry. We don't believe there is another cloud file system that offers the same durability and the same availability. And we designed it to be extremely simple and easy to use. It's fully elastic, and it is multi-petabyte scale. So it scales in both performance and capacity. So simple. Fully managed service, as you would come to expect from AWS. You don't need to worry about managing and configuring all the underlying hardware, storage, networking, and file system layer that you would for file system access. It takes seconds to provision an Amazon EFS file system and then mount it to EC2 instances. The entire process takes a couple of minutes. Seamless integration. It supports industry standard file system protocol with file system semantics. So we support NFS version 4.0 and 4.1. 4.1 is recommended. And so it works with a lot of existing applications and their current APIs. It also has a very simple and straightforward pricing model that we'll discuss at the end. It is fully elastic. You don't have to worry about provisioning any amount of capacity and then adding or even removing storage. All you do is store data in it, and you get charged for the amount of data that you store. Simple as that. And you can delete the data, and then obviously your charges will go down. So nothing to do in terms of configuring it and worrying about capacity. It is multi-petabyte scale. So you can start with as little as a single kilobyte all the way up to multiple petabytes of data. We have our largest customer currently has a file system that's a single file system that's over 600 terabytes. The throughput, the performance, scales as you grow. That's actually one of the characteristics of performance that we'll focus on in the performance portion of the presentation. It also provides consistent low latencies regardless of the file system size. So those applications that have come to expect certain response times, Amazon EFS has very consistent performance profile and support for thousands of concurrent NFS connections. In fact, Amazon EFS performs better the more you scale. Highly durable and highly available. So think of Amazon EFS in the same context as you would S3. Think of it as a regional construct. It spans 3 availability zones. And data that's written in one availability zone is synchronously mirrored across availability zones. So you get extremely high levels of durability. You also get extremely consistent read after write behavior. So a host that writes into one availability zone, that data then, when that write is complete, can be read by a host in another availability zone. Okay? And so we think that makes it an appropriate storage tier for production/tier 0 applications. So EFS is a storage option for EC2. It's a shared file system for our compute, our EC2 instances. So if you were to look at this, again, in terms of the other storage options, here's a way to think about it in relation to EBS. EBS is still going to provide the lowest possible latency across all the storage services that we have. But its throughput will be single gigabytes per second. And you'll see in some of the performance testing that we've done, EFS can scale to multiple gigabytes per second for throughput. EBS is redundant, but stored redundantly within an availability zone. As I just mentioned, EFS is stored redundantly across availability zones. Okay? EBS is mated to its EC2 instance. So you have an EBS volume, and it's servicing an EC2 instance in that availability zone. With EFS, you can scale from 1 to thousands of EC2 instances. And so you see a variety of different use cases here. We see a wide range of customers using EFS for analytics, media processing, content management, web serving, and traditional home directories. So if you need a file system, do you need an EFS file system? So a quick thought process would be, does it require multi-attach, meaning multiple EC2 instances? Do you need multiple gigabytes of throughput? Do you need multiple availability, multiple AZ availability and durability? And do you appreciate the automatic growing and shrinking of the storage? So these are some of the criteria that we think are a really good fit for EFS. Now, I just mentioned that EFS is a shared storage option for EC2, but in addition to that, we also offer EFS via Direct Connect. So now, this allows you to be able to connect your on-premise servers to mount targets in your VPC in Amazon. Okay? So it's either running as a shared file system in EC2 or with EC2 or from on-premise. Now, for on-premise, using Direct Connect, we see 3 different use cases. One is migration. So think of this as if you want to move all of your file data one time. You want to move it from on-premise to EFS. The other use case we see is bursting. So if you want to move some file system data for some period of time, so you can expand or extend your file system into EFS. And the last one is backup or DR. Do you want to make a copy of your files into EFS? The only one that we do not see a good fit for today is tiering. And that's a scenario where you run some of your application using on-premise files and some in EFS. So you're running in this hybrid mode. And we think that the latencies associated with running your application in that hybrid model today isn't really suitable. So that's the only one that we wouldn't recommend. But the other three we see on a regular basis. So again, EFS, it's a standard file system interface with file system semantics that people have, quote, grown to know and love. So it's used for a variety of use cases today. We have customers using it for raster and configuration data, for satellite images. That's Monsanto's using it for agricultural analysis. We have customers using it with TIBCO for enterprise messaging. Customers using it with both ECS, Docker, and Kubernetes containers. Very popular use cases, database backups. A lot of DBAs can very easily then mount a directory out on EFS, and at their time, they can create multiple copies of their database for recovery. We do a lot of web hosting, web serving with companies like WordPress on EFS. So a wide range of use cases that we see out there. Where is EFS? So today, it's in 5 regions globally, 3 in the US, 1 in Dublin, and the other in APAC in Sydney. And we have many more regions planned. So that was the why and a little bit of the when. Let's dive a little bit deeper and get into the what's. So we'll go through the technical and security concepts. So EFS's design is multi-region, so think of it as a regional construct across availability zones. And the file system then represents mount points or mount targets in each availability zone that refer to the same data, right? So it looks like that file system is globally available in that region, okay? It lives inside your VPC. And today, we support 1 VPC per file system. So you can have multiple file systems, but they all live in your 1 VPC. So, to kind of level set, what is a file system? So for one, it is the primary resource for EFS to store files and directories. You can have 10 per account, which is a soft limit. And for any of the soft limits that you see, if you have a requirement for more than that, please come see me. I'll be happy to work with you on your use case and your requirements. The default throughput, the throughput that your file system is capable of without any other restrictions is 3 gigabytes per second. So a fair bit of throughput's available from the very beginning. It's accessible from EC2, of course, as well as on-premise via Direct Connect. We support EC2 Classic via Classic Link. The other major technical component is the mount target. So the mount target lives within a VPC. You would create mount targets in each availability zone, and there'd be IP addresses that resolve to DNS names for your mount targets. So again, it's going to look like a single namespace in your region. So even the mount target is highly available. So mounting EFS, we support 4.0, but we highly recommend 4.1. That's the font size effect. And we support and recommend Linux kernel 4 and above with all the standard or default mount commands. So this process, launching the EC2 instance from the console, connecting to it, making a directory and mounting the EFS file system, i.e. making it available for use and access, takes about 2 minutes from beginning to end. And that's the syntax that you would use there at the bottom. These are the kernel versions, the mount options, and this is the actual syntax down there at the bottom. It's the standard or default mount options. All right. We also have resources for EFS. So we support tags. So this is custom metadata, right? It's mutable metadata. It's a key value pair. You can create up to 50 tags per file system. So if you wanted to add more meaningful information, if you will, like a project name or a customer name, location, you can add that in with the file system. Bless you. We mentioned mount targets. You can have multiple mount targets per file system. They live in your VPC, one per availability zone. Security groups. So we support the standard VPC security group. It's got to be in the same subnet. Up to 5 per mount target. I don't know how I got that little mouse up there. And you have to allow TCP port 2049 for access from your NFS clients. We support 3 layers of security. So think of it as a network layer / physical layer, and then administrative layer, and then file layer. So we control network traffic using VPC security groups and network ACLs. We support standard POSIX permissions for the file and directory access, and administrative access via API using Amazon's AIM, Identity Access Manager. So you can use the console, CLI, and/or SDK to do any of these tasks, from creating the file system to tagging it, deleting it, and viewing details in your account. So you have 3 different ways to manage your EFS file system. Here's a full list of the available CLI commands. And again, I see people taking photos, but I think if you fill out your survey, you get the slides. So that's another option, another way to incent you to fill out the survey. Let's talk about EFS performance. There's a good deal of material in the performance section. So EFS was designed to be a general purpose file system with an option for extremely high performance. So the design thought was to be able to cover a wide range of performance profiles to meet that wide range of use cases. So how do we do that? How can we cover this wide set of performance requirements? So again, if you think about the architecture, it is a distributed file system. It's a distributed data design. So data is copied across multiple different hosts. It's copied across multiple different storage systems on the back end. And so this gives us a lot of throughput options. When you configure your file system, you'll have 2 choices, 2 modes of operation. The first is general purpose, which is the default, and it is essentially, as named, it is intended to meet 80 to 90% of the use cases. The other mode is max IO, which is really meant for large scale-out workloads, data-heavy workloads, that essentially give you unlimited throughput for that workload. I will note that you'll see in the chart, the general purpose or default file system mode does have a limit of 7,000 operations per second. So when you think about your particular application or workload, you'll have to see if that's one of the limits that you would encounter, which is one of the criteria that might move you into the max I/O mode.
Does that include metadata operations or just read write?
Yeah, great question. So just to repeat it for the audience, does that include metadata operations or just read write? And it is more read write. So the way that 7,000 is actually calculated, the metadata doesn't account for it as much. I can go through the actual specifics of it. So we use CloudWatch to measure a lot of these characteristics. I'll give you a full list here in a moment. But this particular one, %IO limit, if you monitor this, might give you an indication if you're better off in max I/O mode. So if you find that you're consistently peaking your %IO limit, then that might be a condition where you want to look at max I/O mode. So in addition to those two different modes, another aspect of performance is a bursting model. So if you folks are familiar with EBS, it's got a similar concept. So EFS's performance is largely tied to the capacity or size of the file system. When you create it, all file systems start with a burst performance of up to 2.1 terabytes. All file systems will start with a minimum burst throughput or baseline performance of 100 megabytes per second. And the formula is 50 megabytes per second for every terabyte of data stored. That's going to be your baseline performance, 50 megabytes per second for every terabyte of data stored. Your burst essentially doubles that. So if you have 2 terabytes, you're going to get up to 100 megabytes. Your burst would be up to 200 megabytes. So that's the verbal. Here's the visual of what I just described. So here's kind of a quick chart just to illustrate that formula. So again, size on the left, everyone starts out with 2.1 terabytes. Then your baseline performance is going to be dictated by your capacity. Your burst will be twice that. And there is a time that you can burst for. And so what you'll see is that after a terabyte of data stored, you'd be able to burst for the full duration on the right side column. So you'll be able to burst for 12 hours. And we have a lot of customers whose workloads are such that users come in, they work their day, let's say it's 10 hours in the office, so the application's working and it's consuming burst credits, but then they go home and essentially the burst bucket fills up overnight. So essentially they never have to worry or manage about the burst credits. And so the way to think of it is, think of it as a bucket that's getting water, like a coffee machine that's dripping coffee into it. If you are exceeding your baseline performance, you are essentially drinking cups of coffee. You're taking that coffee and you're pouring it out. If, though, you're drinking it a lot slower than it's dripping in, you're essentially assuming or adding burst credits to your bucket so they can be available for later use, up to the maximums based on capacity. Another key characteristic of performance is size of the I/O. So obviously, as any given I/O gets larger, your throughput will go up. So this is just a quick example. Here is actual performance testing. So what you'll see is that as you scale out in terms of the number of threads, meaning as you parallelize your workload, you're going to see linear scale in terms of EFS throughput. So the more you can parallelize your application in terms of threads and instances, you're going to see EFS essentially scale to meet up. These are the relevant CloudWatch metrics. So we talked a little bit about %IO limit, which is the bottom one there. And that really helps decide if you're in the right mode, the right performance mode. Burst credit balance, which is the second item, well, the second row on the list. This will let you monitor how much of that burst credit you're consuming and if you're about to reach the balance. Permitted throughput, that actually talks to the 3 gigabytes per second soft limit that I mentioned earlier. So again, if your application is data heavy and you need more than 3 gigabytes, please let me know, and we'll get that submitted for that restriction lifted. So we did do performance testing on a couple of different workloads. So one was large files. So this was using media files from a few gigabytes to over hundreds of gigabytes per file. And we read data from both S3 and EBS. We also did a small file test with file sizes ranging from 64K up to 256K. And again, in our two complementary storage services were our sources. And then we parallelized the operations in this testing using a tool called GNU Parallel. There's the link to it down there. So this essentially takes jobs and makes them run wide, similar to xargs, and replaces loops in shell scripts. And so it makes sure that the same output from the commands is what you'd had if you run the commands sequentially. So this gives you another visual about time to take, time to copy files using number of threads. And essentially the punchline, if you will, is that the more threads you have, obviously the faster you will transfer data. And this was using GNU. The actual syntax is here. So there's essentially two commands to create parallel destination directories and then to copy the files themselves.
So your chart, what was the x-axis? It wasn't labeled.
Oh, go back. There we go. Yeah, so it's number of threads, but they weren't specified. Yeah, the actual number of threads were not specified, but you will see that in the actual testing. So here were the results. Large files, small files. So we got 50 instances cranked up for the large file test, 4.2 gigabytes per second, and we simply stopped at 50 instances. So 4.2 is not the limit, it's simply where we stopped in terms of the testing. And what you see in the graphic is that it's extremely linear and consistent and predictable, right? All those 50 instances. Small file test, we use 300 instances. Again, we want to really parallelize and take advantage of that distributed data design. So 1.6 million files per minute, and the lines are much closer together, but you will see the same characteristics. They are all very consistent and very predictable. So back to your question, I thought that we actually had the threads in here. So it's got 300 instances, but does not have the threads. If you'd like to, I'll give you my card afterwards, and I can get you the actual numbers behind them if you'd like. Okay. So large files or small files? Both suitable. All depends on, in our testing scenario specifically, how much you want to parallelize that workload. So for the performance summary, distributed data architecture. You got multiple hosts with multiple copies of the data across multiple AZs. Go parallel. That's kind of the number one rule in terms of maximizing your performance with EFS. So maximum amount of threads, maximum amount of instances possible. Test. Again, it's going to be standard file system protocol, standard file system semantics, but please do test your application, see how it behaves. If you would like, come see me at the front afterwards. I'll give you my business card. If you plan to test, we are happy to test along with you and see what we see from our end, provide you feedback, recommendations, help you get through to a successful outcome. We'll help you analyze it. And again, the burst credit piece, I know I went through it quickly. Hopefully the supporting material will help in terms of your planning and design. But again, the burst credit piece is one that I think people have to calculate and plan for in terms of their configuration. So essentially, you need to have enough data to drive the throughput that your application needs. And when we did our testing, we used EC2 spot instances. So we took advantage of our own on-demand bid process, and we were able to do all that testing, spin up all those instances, and then consequently spin them down for less than $5 an hour for those 300 instances. And we see the combination of them in certain workloads, like big data analysis. We have customers that use us in the financial services space to run financial risk simulations. So they will essentially be quiet for a month or so, and then all of a sudden we'll see a large spike in usage, and they'll be spinning up thousands of instances, sometimes in containers, running their analytics, producing those reports, providing them to their customers, and then spinning them all down. So that's kind of a combination of the two that we see out there. All right, so EFS's economics. So I mentioned that we think EFS is unique and differentiated in the industry in terms of its design, its durability, its availability. If you wanted to BYO, if you wanted to build your own, you certainly could. You could take EBS volumes with EC2 instances. You can implement a shared file system layer for the NFS portion, and essentially build your own file system in the cloud. And we've had multiple customers that did that using solutions like Gluster in the cloud and found them very difficult to maintain. So this is what a BYO would look like. So essentially, when you're looking at EFS, what you're actually getting is multiple EC2 instances with multiple EBS volumes that are all interconnected so that you can access that same data from any client in any AZ, and we copy or mirror that data between availability zones on behalf of the data. So you get storage, servers, inter-AZ networking costs, all of that is what is included in the EFS managed service. Okay? So many different cost points. The way that looks economically is, if we take an example, this one happens to be based on 500 gigs. You start out with an EBS volume. You may choose to use elastic volumes and right-size it to 500 gig. A lot of customers give themselves a little bit of wiggle room. So let's say we go 600. Here is how those other costs would break down. You've got the GB2 EBS volumes. You've got your compute instances. There is an inter-AZ data transfer cost. So that's estimated in this case based on the amount of data that you're sending back and forth. So you're looking at all in about $600 per month, not including the file system layer. So whatever is involved in terms of the file system you implement, and not including any soft costs of management and administration. I mentioned that EFS has a very simple pricing model, and that is 30 cents per gig per month in US regions. There's no other billing dimensions. And that's based on the amount of data that you store. And the way that looks is this simplified version. We've got multiple NFS clients accessing a single namespace with mount targets in each with a very simplified pricing structure. Okay? Simple and fully managed. Again, you can configure a file system, and there's no charge for that, per se. So there's no commitments or upfront fees. You don't have to provision anything in advance. 30 cents per gig per month in those 3 US regions, 33 cents per gig per month in E1, and 36 in Sydney. If you have requirements for other regions, and I know that certain regions might be of particular interest to this audience, again, I'll be up here in the front. I can give you some timelines. We have a number of different references. So again, all of this is provided in the slide deck, available to you after the summit. There is a walkthrough where you could configure the file system hands-on, and that link up there. 3 minutes. I think it clocked in at just under 3 minutes in terms of getting the whole thing spun up and configured. We have several reference architectures, so a number of the use cases that I described are available online for you to take a look at as a starting point for your designs, and then quick starts and quick labs to give you folks more reference material. All right. I wanted to leave myself like 10 minutes for Q&A, and I'm actually just a few minutes ahead of that. So with that, I wanted to thank you for coming to the session. Thank you for attending the Worldwide Public Sector Conference. Enjoy the reception. And again, I'll be up front here to answer any specific questions. Thank you.